Hi and welcome to this next video on the mechanics side of the course where we're looking at equations of motion, and in this video we are going to get into some things that are referred to as the SUVAT equations, which really are kind of the meaty part of this section of the course. So, SUVAT equations, what we've got is a bunch of equations that are being described by 5 variables which refer to the motion of a particle. So we've got S, which is displacement, U, which is initial velocity, by which we mean the velocity that the particle is travelling at when we start observing it, i.e. at the beginning of the motion when t equals 0. We've then got V, which is the velocity at any given point in time during the motion, so there's a clear distinction between these two things here. Then we've got acceleration, which is A, and that absolutely must be constant throughout the motion. We can all deal with variable acceleration in a separate section later on, and variable acceleration changes everything, so this is just constant acceleration. The acceleration is the same throughout. And then we've finally got time. So SUVAT, SUVAT. And for me, this is such a structured part of mathematics. We just kind of start off, think about each of those values. What have we got? What haven't we got? List them, and then have a bit of a think about what is an appropriate course of action from there. And you'll see me doing that throughout this video. So, first of all, we've got to figure out where these equations come from. I have seen questions in examinations that ask you to do variations of this in terms of deriving these things, so it's useful to know where they come from. So first up, there's our velocity time graph, which we're hopefully by now familiar with. And if we think about that as a y equals mx plus c, instead of the y on the vertical axis, we've got v, which is velocity. Instead of x on the horizontal, we've got t, which is time. And then the gradients, the m part of it, is acceleration. We've talked about that before, change in velocity over change in time. And the intercept is the velocity it's starting at to begin with. So in our context, it's our initial velocity, which is u. So that's u is that bit there, a is that bit there. Put all that together, we've got v equals u plus at. So intercept, gradient, and there's our first SUVAT equation. That's probably the simplest one to use. Right, and on we go. Now, let's have a look at our curve again. This time we are going to be looking at the area of the curve, which we know is the displacement. And so, given the fact that we know that our displacements here, this shape is a trapezium, we've got our formula for the area of a trapezium, a plus b are the parallel sides. So that side there is u, that side there is our velocity, so that's v, and h, which is the distance between them, is just how long it's been going for, that's time. So straight away, just plug in u, v, and t into our trapezium formula. Straight away gives us that one, and that is equation number 2. What we can also do with this graph is, if we look at the area in a slightly different way, if we split it into a rectangle and a triangle, what we've got here is that distance there on our rectangle is just the initial velocity. This one here is the change in velocity, the increase in velocity, which is just acceleration times time. And so now we can create a formula which just adds together the area of the rectangle and the area of the triangle. So here we go. S equals area of the rectangle, that's just going to be u times t, so that's that bit. The triangle here, half base times height. The base is t, the height is a times t, so we've got half at squared. And there we go, so that is another way of calculating the displacements. And you might be thinking, why the heck have we got 2 formulas that basically do exactly the same job? Well, the reason for that will become clear in a little moment's time. Moving on. If we go back to equation number 1, which is v equals u plus at, do some rearranging. So we've got to rearrange for t. So t equals v minus u over a. And now what we're going to do is substitute that into equation number 2. So there's my equation number 2. Plonk in this expression for t. There it goes. And you'll notice on the top you've got difference of 2 squares. So we multiply out those brackets. That's going to give us v squared minus u squared. On the bottom I've got 2 times a, and then the last couple of jobs I'm going to do firstly is move the 2a across, and then get the u over on the other side, so it's saying v equals, and we've got v squared equals u squared plus 2as. That's equation number 4, and basically we're going to do a very, very similar job to get our 5th and final equation. So what I've done this time is taken v equals u plus at and rearranged it so u is the subject, and we're going to plot that into equation number 3, which is that one. So I'm going to take the u here and replace it with v minus at. So we've got that. Do some multiplying out of the bracket. You'll notice I've got a minus at squared here. I've got plus half AT squared here. So we've got minus 1 lot of AT squared here, plus half AT squared there. So put those two bits together, I'm going to get minus half AT squared, and that is equation number 5. And you'll be pleased to know that's all the equations that we've got. Now, it's no coincidence we've got 5 variables, we've got 5 equations, and the reason we do that is that each equation emits a different variable. So if we look at the equations here they come. So the first one, equation number 1, is the one that doesn't use S. This second equation doesn't use A. Third equation, it's V that's missing. V squared equals U squared plus 2S. That's one that doesn't have T in it. And then the final one is the one that doesn't use U. And so what that means is we've got a choice of equations we can use when it comes to solving problems, and what we're looking for is to pick the right equation. We're looking for the variable that we don't know anything about, and if we know nothing about it, don't want to find it, that dictates our choice of equation to use. So what you'll tend to find in most cases, you'll have 3 variables, you'll be trying to find the 4th one, and you've got a 5th variable, which is the one you don't know anything about, which is the one that kind of determines which is the appropriate equation to use. Final thing to mention is that these things are in the formula booklet, but by the time you finish the course you should know them inside out, back to front and upside down, but they are there just in case your memory needs refreshing when you're in the exam. Okay, so let's have a look at some examples. Now these things tend to be quite wordy, so it's about looking at the text that's written and just picking out your 5 values, SUVAT, picking out the ones that you've got and then going from there. So here we go. First thing I'm going to do every single time on one of these, once my car's gone across the screen, is listing the variables. So SUVAT, there they are, so we've got to decide what we've got. Right, so first of all, S, we're told, there you go, it's 600 metres, so we've got that one. U, when we start observing it, it's travelling at 35 metres per second, so that's our value for U. V, we're trying to find its speed, so that's the one we're going to need. Technically speaking, that should be saying velocity, but speed and velocity tend to get used interchangeably a little bit, so we are looking for velocity here. Acceleration, we're told assuming constant acceleration, but we don't know what it is, and we're not being asked to find it, so I'll put a cross by that one. Don't care, don't know, don't want it, don't want to use it. And then we are told it's crossing the finish line in 12 seconds. So now, based on all that, our next job is to decide which equation we're going to use. You might want to kind of pause the video quickly, have a bit of a think, have a look and decide which one it's going to be before I give the game away. And hopefully you picked equation 2, which is S equals U plus V times by T all over 2, the one that doesn't involve acceleration. All I've got to do now is plug in my values. So there they go. Do a bit of rearranging and solving. And so we end up with our answer, which is it crossed the finish line travelling at 65 metres per second. Cool. On we go. So another question. Skier pushes off the drop of the slope with a speed of 1.5 metres per second and accelerates at 2 metres per second. The slope is 22 metres long. How long does she take to reach the bottom of the slope? How fast is she moving? Okay. So again, what first we're going to do is wait for my skier to go past, and then we're going to do the bit how long does she take to reach the bottom of the slope. SUVAT. So S we know is 22, U we're told is 1.5, V we don't know at the moment, A accelerates at 2 metres per second, and T, how long does she take to reach the bottom of the slope? That's what we're trying to find. So there we go. So now again, let's have a little think. Can you work it out for yourself? Which is the equation that doesn't involve V? And hopefully you've realised it's S equals UT plus half AT squared. And again, plug in all the values. Now, in this particular case, what we've done is we've ended up with a quadratic. So that's going to need solving. And like I say in the PowerPoints I'm going to do it old school and then factorising. But obviously you've got your calculators and your equation solvers on them. So however you choose to do it, there's the factorising. Now, I've got 2 answers, and you will get 2 answers even if you use your calculator. But clearly, time is not going to be negative. So we can discount that one, so we know that it's taken 4 seconds to reach the bottom of the slope. So that's part A done. What about part B? How fast does she move when she gets to the bottom of the slope? Well, if you look at it over here now, you'll now see that we have got 4 out of 5 variables, and what that means is we can pretty much use any of the equations at all, except the one that doesn't use V. So it doesn't really matter which one I pick, but I'm going to go for that one because it's just the easiest. V equals U plus AT. Plug in the values, and there we go. She's travelling at 9.5 metres per second when she gets to the bottom of the slope. On we go. So, barrel of a shotgun, 0.9 meters long, and we know the shot comes out of the barrel at a speed of 214 meters per second. Find the acceleration in the barrel. Okay, so SUVAT, what do we know? So clearly that's going to be 0.9. U, well, often you find that U is implicit, because obviously at the start when we start observing this thing, the bullet isn't moving, so we know that U equals 0. V is 240, the speed it's coming out of the barrel at. Acceleration, that's the thing we're trying to find. T is the one we don't know. So we're going to use equation number 4 this time. So V squared equals U squared plus 2AS. Plug the values in, and we've got our acceleration, which is 32,000 meters per second. That's a hell of a figure. Right, on we go. Length of time it's in the barrel. Again, similar thing as before. We've now got all the equations, all the variables, so we could pick any single one. So we're going to go for V equals U plus AT. And so, again, plug in the values, and we can see that the bullet is in the barrel for 0.075 of a second.